Alright, in this video we're going to write the equation for the perpendicular bisector of a segment, except we're going to do it in probably the most ridiculous, complicated method possible, because there's a problem in your problem set where it asks you to do this, and there's a lot of heavy algebra in here, and I just wanted to walk you through an example for it. So just as a reminder, the perpendicular bisector of a segment is the set of all points that are equidistant from the two endpoints. So every point on this line is the same distance from A as it is from B. So if I'm anywhere on this line, I could travel directly to A or directly to B, and it would be the same distance. So that's what all the points on the perpendicular bisector are. In another video, I talk about how to draw that perpendicular bisector. So I have sketched out a perpendicular bisector here. The equation for this perpendicular bisector is y equals 2x plus 2. And we can see that because it crosses the y-axis at 2. That's our y-intercept, our mx plus b form. And the slope is 2. It's rise over run, up 2 over 1, 2. So slope is 2, intercept is 2, 2x plus 2. So y equals 2x plus 2 is the equation. But we're going to derive that equation from the fact that the points on the line are equidistant from both endpoints of the segment. Now, in an earlier video, we wrote out formulas for how to write a formula that could be used to calculate the distance from any random point to some given point. And we used a specific example as -1, 2. Okay, so here, sorry, a little glitch there. We have two formulas. This formula right here will calculate the distance from any random point that has x and y coordinates to A with coordinates of -2, 3. And this formula right here will calculate the distance from any random point that has x, y coordinates to point B with coordinates 2, 1. So I can plug in coordinates for a point, and this formula will spit out distance to B, and this one will spit out distance to A. And we should be able to take a point on the perpendicular bisector and plug it into both formulas and get the same answer. So let's see if that happens. Let's pick the point -2, 2. Right, so I'll do distance to A first. So distance to A. Okay, that's my big square root bracket. Our y coordinate for this point is 2. So 2 minus 3 squared plus x coordinate is -2. -2 plus 2 squared. So let's see, c is equal to, let's see, 2 minus 3 is -1. Wait a minute. This is -2 right there. Mistake-o. That should be a -2. -2 minus 3 is -5 squared plus, let's see, -2 plus 2, that's 0 squared. So let's see, then -5 squared is 25 plus 0, and then c, square root of 25 is 5. Okay. So now let's do distance to B. So let's see, let's go distance to B. So let's get our formula out here. Okay, so our formula says y minus 1 squared, so our y coordinate again is -2. So -2 minus 1 squared plus x minus 2. So that's our x coordinate is also -2 minus 2 squared. So let's see, our big square root bracket. -2 minus 1 is -3. -2 minus 2 is -4 squared. And see, -3 squared is 9. Plus -4 squared, that's 16. So see, 9 and 16 is 25, and the square root of 25 is 5. So I plugged in the coordinates for this point on the perpendicular bisector. We did the calculations, and we see that the distance from here to A is 5, which we can actually just count spaces, 1, 2, 3, 4, 5. And the distance to B is also 5, and if you look, 1, 2, 3, 4, 1, 2, 3, it's that 3, 4, 5 right triangle. So 5 either way. So now the question becomes, how can we use these two formulas to put them together and come up with an equation for this perpendicular bisector? So here's where the really heavy lifting comes with the algebra. So you got your two formulas. And so there exist some numbers, some pairs of numbers, some coordinates, such as -2, -2, that I could plug into formula A or into formula B and get the same answer either way. And we want to find, all of those. And so when we're talking about all the pairs, the XY pairs, all the coordinates, that something is true about them, there's something true about all of these, then I can set up a statement that says that, right? So I'm going to set up a statement that says that there exists some XY pairs that I can plug into this formula, and I'll get the same answer as if I plug them into this formula, right? Well, so this formula works out to be the same as this formula. And the same as, in mathematics, is equals. So we're just going to simply write, I'm going to give myself a lot of room here, that our first formula, which was y minus 3 squared plus x, well, that's awful dark. Hold on a second. All right, so we're just going to write that our first formula here, which is y minus 3 squared plus x plus 2 squared. So, and if we were to plug in an x and a y, I'd do all the math, and I would get some outcome for that formula. And that would be equal to the other formula's outcome, which we don't know it yet, so what we'll write is y minus 1 squared plus x minus 2 squared. So what we're saying is there's some x over here, x and y. I'll plug them in. I'll get some kind of number over here. I'll plug the same x and y in over here, and I'm going to get the same number over here. This is going to be true. So we're starting out with the assumption that this is true. And then what we're going to do is we're going to go through a process of sort of rewriting this equation over and over again until we come up with something that's a little easier to deal with. Because there's lots of stuff going on here. So let's kind of simplify things a little bit. We'll just follow our equation solving processes, so things that we know we can do with equations without changing their truth value or the values of their solutions or whatever. First thing I'm going to do is I'm going to square both sides. So I'll get rid of these square root brackets. So I'll end up with y minus 3 squared and x plus 2 squared equals y minus 1 squared and x minus 2 squared. So I just squared both sides. Next, I'm going to expand all of these binomials. That gets ugly. So let's see. If I expand this one, I get y squared minus 6y plus 9 plus x squared plus 4x plus 4. On the other side, we get y squared minus 2y plus 1 plus x squared minus 4x minus 4. Okay. So that's just expanding binomials. You could imagine x minus 2 basically means, if I say square x minus 2, it's x minus 2 times x minus 2, and use a FOIL method. Okay. Something from back in algebra. So next, there's just a whole lot of combining like terms to do. So let's see. I have, let's see, over here, well, actually, instead of combining like terms, let's subtract some things. So I could take away, I've got a y squared and a y squared on each side. So let's just take those away. Okay? So I would be subtracting them, but I don't want to show all the work because it'd be a lot of extra steps. So I'm just going to kind of cross them off as I go along. Let's see. We have let's see, negative 6y. Let's look at the 9. 9 and 4 makes 13. And over here I have 1 and negative 4 makes, maybe I should start writing this out. Negative 6y plus, I got my x squared. Actually, no, I can just cross out the x squareds too. Right? Negative 6y, let's see, plus 4x plus 13 equals negative 2y. Let's see, minus 4x. And let's see, plus 1 minus 4 makes minus 3 overall. So, the reason I could just cross off the 2x squared is I have 1 on each side, so I'm just sort of subtracting them without actually showing all the work. Alright, so let's see, let's start by, I don't know, we'll add 6y to each side. So that's going to leave us with, oh, that was nothing. That's going to leave us with 4x plus 13 equals 4y minus 4x minus 3. Hey, Mackenzie.
I got your mail for you.
I'm working right now. I'm working. Okay. All right. Let's go ahead and add 4x to each side. So that's going to give us 8x over here plus 13. I got my 4y minus 3. So let's see. Next, I'm getting off the screen a little bit here. So next we have, let's see, add 3 to each side. So that's going to give us 8x plus 16 equals 4y. And then we're going to divide both sides by 4. So 8x divided by 4 would be 2x, and 16 divided by 4 is, 4 equals y. And something's wrong here, so I have to figure that out. Oof, I found my mistake. So, see, this binomial expansion should have been plus 4 over here. 4 and 1 would have made this plus 5 plus 5 plus 5. So then we subtract 5, which gives us 8. 13 minus 5 is 8. And then divided by 2. Okay, so there. So. Anyways, so again, we start out by saying that the two expressions are equal to each other. Then we squared both sides to get rid of the square root brackets. We expand the binomials, hopefully not screwing it up like I did the first time. And then we just simplify the expression by combining like terms and subtracting the same amounts from each side until we whittle it down to the equation for the perpendicular bisector. And what this means is that any two xy pairs that fit this equation, so if I can plug an x and a y in here and they come out to be true, then they're points that are on this line, and they're also, going back up to here, the same distance from either A or B. And that's a lot of work for one problem.